Good afternoon and welcome to our talk, which is called Taming the Spaghetti, Rich Web Applications with Errai. I'm Jonathan Firth.
Hi, and I'm Christian Sadek. This talk is about building maintainable, large-scale web applications with the JBoss Errai framework. But we have to start with some sad news. Someone near and dear to all of us could not be with us tonight.
That's right. Sadly, server-side rendering of HTML pages has passed away after a long battle with Ajax. Now, of course, this isn't news. We put its end date probably about 2 years ago, and we didn't come all the way here to Java 1 to tell you that server-side page rendering is old news. But what we would like to talk about is the frameworks that we all use, the ones that were developed and loved by all of us for many years, were developed in an age when web browsers were not really reliable enough to have an application live full-time in a single page in the browser. I mean, I can personally remember the hundreds of hours and the late nights staying up trying to make a single page web application look the same in IE5 and Netscape 4. It's like a horrible game of whack-a-mole gone wrong. But
yeah, now I think it's fair to say that the worst nightmares are over, and we can count on compatibility and speed in JavaScript, CSS, and DOM. Plus, we have libraries that fill in the remaining gaps, like jQuery and the Google Web Toolkit. So also, browsers have access to more computational power than they had ever before. We all just have to look at our phones for evidence.
that's right. If you think about your whole web application as a distributed system, you think about the database tier, the middleware tier, and then all of these clients out here, all of these now fast and reliable runtime environments, and you weigh the amount of computing power that exists in your distributed application, you'll find that most of the computing power is in the thousands of clients, the web browsers, that everybody's using to interact with your web page. So we really should be taking advantage of this now.
So yeah, in short, we have those web browsers, and they're really good application deployment platforms. So why don't we put more application code, more of our application's logic into the browser?
Right. Well, why don't we? I think I'm sold.
Okay.
This is compelling. I think let's actually just change this into a hands-on lab. Everybody get out your laptops. We're going to crank out about 150,000 lines of JavaScript in the next 2 hours. Who's with me? We're going to get started?
Well, not so fast,
What?
Jonathan.
What?
Well, I already have thousands of lines of Java code in my app. Are you saying I should ditch that all, rewrite it in JavaScript, all of it?
Well, yeah, why not? We have these wonderful browsers. We've got all of this computing power in the client tier, and we want to take advantage of it. We don't even have to pay for those CPU cycles. And, I mean, who among us has laid awake at night just wishing you could throw away all of your legacy code, start over greenfield?
Okay.
Just do it. I say we go for it.
But what about security and data validation? I can't do that completely in the browser. The user is in complete control, or a hacker would be in complete control of that logic.
Yeah, okay. So that's a valid concern. We can't rely on the browser as a secure and trustworthy computing environment. Even if it's a nice, consistent deployment environment, it certainly can be tampered with. So we'll keep that code. We'll keep our business model and our form validations and our security checks. But I'm also going to implement those in my new client-side code base because I want to do form validations on every keystroke. I don't want to do server round trips for all of this stuff. We can make these web applications fast and responsive, so we need this code on the client.
Okay, let me see if I get this right. So you're going to implement the whole business model again in JavaScript with identical validations. And then you're going to keep maintaining and developing this in lockstep with me over the next 5 years.
Okay, well, I think you might have got me a second time there because I've been in this situation. I've led a team that was at loggerheads with another team trying to keep two code bases that do essentially the same thing in lockstep. They were written in different languages, and it was somewhat of a nightmare. It's not just doubling the effort. It's creating a lot of drag on both teams. So no, I don't want to keep my JavaScript code in lockstep with your Java code forever.
So if we want to work in the same language, that essentially means we have two choices. You can write everything in JavaScript or everything in Java. Okay,
I think I can agree with that statement. And now that you've framed the debate that way, I think I would prefer to choose Java. I mean, just thinking about the IDE tooling that I love, just the rename refactoring alone, I would hate to give up completely reliable rename Don't think twice, just do it. I also love call hierarchy, find usages. I'd feel like I had my right arm tied behind my back if I was developing a web application without these simple tools that we take for granted.
Yeah, plus we have an existing team that's all made up of Java developers, and there's a large talent pool out there.
Right, that's true. Our developers are already really good at writing solid, clean Java code, and I've seen things go off the rails if we try to dive in and write a giant application in a language we're not entirely familiar with. So that's another good point.
And another point is you don't want to give up your libraries, right?
No, that's true. That legacy code base that I was laying awake at night thinking about rewriting, actually we've improved that recently, and now we've got like the Google collections in there, the Guava libraries. I don't want to give all that up and go back to just plain lists and maps and the stuff we get in JavaScript. So, okay,
so
Java.
we've settled the debate.
Yeah.
We want to be able to use Java on the client, but obviously we don't want to use applets because that was a mistake in history.
Yeah, just check the last 4 or 5 weeks of news and you'll see that's not a popular choice now.
Okay, so why don't we use the Google Web Toolkit compiler to compile our Java to JavaScript? Not only will it translate our code, it will give us cross-browser support, and it will apply a lot of heavy upfront optimizations to our code so that the JavaScript becomes smaller and faster than any handwritten JavaScript we could come up with. And it will also give us development mode. The code and refresh development experience, you change code, you just refresh the browser. And also, it will allow us to debug client and server-side code as Java code in our IDE.
Okay, well, this sounds great. We don't have to give up code and refresh, and we can keep programming in Java that we're familiar with, and we've got the great tools. So why doesn't everybody use this all the time?
Well, it seems there are a lot of misconceptions around the Google Web Toolkit.
Okay, actually, I know one of them. One thing that I hear a lot from people when I've told them that I'm working on this Git-based framework at JBoss, they say, well, I would love to use the Google Web Toolkit, but I really don't want to commit myself to writing all of my user interfaces in this programmatic procedural UI framework that's kind of like Swing or AWT. I much prefer declarative layouts and HTML and templates and this kind of thing. But the truth is, that's just one way. It's true at the beginning. That was the only way you could make a GUI in Gwt. But now Gwt offers the UI binder framework, which lets you declare all of your layouts in XML. It's not dissimilar from the way you create layouts in Android. We also will talk about later a declarative templating system that we include in Errai that's based on HTML5 template files. And of course, the Google Web Toolkit isn't a firewall from the underlying DOM that's living there in the browser window. So you're totally welcome to just go and manipulate the DOM objects using that same horrible W3C DOM API we have available to us in the browser. So if you like to do that, you can. Yeah. Any other reasons that we might not want to look at this?
Now that myth is busted, there's another one we hear very, very often, and that is that there's some magical server-side runtime dependency that makes this all work, where the truth is that there is absolutely no runtime dependency, or there has to be no runtime dependency. All the compilation happens at build time, so you deploy static and perfectly cacheable JavaScript to the server.
Okay, so there's no magical server time compiler runtime. That's good to know. So that's sort of, hopefully we can all be on the same page about what exactly the Google Web Toolkit is and what it isn't, and help dispel some rumors. But we're here to talk about Errai, which is the framework that we work on full-time at JBoss. So what does Errai give us? Well, Gwt is really hyper-focused on being the best, smallest, fastest, tightest code that it can produce, and whenever there's a trade-off to be made between this user experience and speed versus developer experience, they tend to lean towards the user experience. They really want to stay hyper-focused on performance. But we're taking the balance a little bit more towards us because we're developers. We like making software and we like enjoying making software. So we have a few mantras that we use when we're deciding how to get things working in Errai. First of all, we say declarative rocks. We like to declare what our application does. Sort of the bones and the structure of the application should exist in the bones of the code. So we have a lot of annotation-driven things, and a lot of just structural expressions are done in the structure of the code rather than hidden away in procedural logic. The other thing we say is boilerplate sucks. I mean, this is a common criticism of any Java framework, and it's come so far in the last 5 years, you wouldn't even recognize Java anymore if you stopped using it 5 years ago. And we're trying the best that we can. If the framework can infer something for you, we don't make you type it out and we don't make you read it. So we try to keep boilerplate to an absolute minimum. And finally, and maybe most importantly, we say code it once. And this is what that whole dialogue at the beginning of our talk was really getting at, is that if we can write code one time, maybe we were thinking it was going to run on the server, and we decide later, actually we want this code to execute in the client instead or as well. It should be trivial to just take that code that we wrote, maybe move it to another package to indicate where it's supposed to run, and then it will just work. It will do the same thing in the client as it was going to do on the server, and vice versa.
So what did we do to turn these mantras into reality? So the most important part is that we made a lot of existing server-side APIs available on the client. So they can compile the JavaScript yielding the same results. That's, for instance, the CDI API, Ajax RS client, and JPA. We also have what we believe is the most unintrusive marshalling system out there that imposes practically no limitations on the objects that are to be marshaled. And we have communication mechanisms that tie all of these features together.
Right. Well, this all sounds great. Now, how would I get started with a project like this? What does it look like?
Well, it looks like a typical Git project and a typical Java project. So you have that source main Java folder, which all Maven users are familiar with. It has the Git XML top-level module descriptor, which just defines which other modules we inherit and just gives our module a name. And then, most importantly, we have a client, shared, and server package where everything in the client and shared package gets compiled to JavaScript, and all the code in the server package will just be deployed as bytecode as with any other regular Java web app. You have your source main web app folder. That's where you put all your static content and your deployment descriptor. You're all familiar with that. And the only thing that Errai adds, and remember, because we say boilerplate sucks, is this Errai app.properties file. And in 99% of the times, this is an empty file. We just need it as a placeholder for class path scanning, so we know where to start looking for annotations that we have to process.
Right. So I guess it's time to dive in, talk about the first Java EE feature that we've implemented in the browser on top of Git, and that is CDI. Who here is familiar with CDI? Should be, yeah, most people. That's great. So we'll just go quickly through what this is. This is exactly like CDI you would have used on the server. Here we're looking at two features of CDI. One is the dependency injection feature, and the other is the eventing feature. So at the top code block there, we have injected a @updated event of document, and we're calling it updated doc event. So what this does for us is it asks the container to provide an instance of event, and event is a CDI type that it's an interface that allows you to fire an event. And the type parameter, of course, is the type of object you want to fire as the event object. So in this case, it's a document. Now the twist with CDI events is that you can, or CDI everything, is that you can qualify it with qualifiers that you made up on your own. So @updated in this example would have been a new annotation we introduced in the application code itself. So we're saying here, inject a way of firing an updated document event. And so we called it updated doc event. Now, in the bottom code, this is how we would actually fire the event when we want to. We've just come up with an arbitrary button click handler. And so we just say updated doc event dot fire document. And document is just any instance of document that we want others to know about. So, of course, this is a decoupled, events are a decoupled way of building a system. So the observers are completely separate from the place where we fire the events. And so here's how you would create an observer in CDI. You simply make a method, any name, any access type. It doesn't have to be public. And then you say @observes. You put as many qualifiers as you want there, 0 or more. And then you say the type of event you want to receive. So in this case, it was document. And then the container will invoke this method with the instance of document every time it's been fired from wherever. And in Errai, when we say wherever, we really mean wherever. So in normal CDI, when you fire an event, it's just inside of the container. It's a local method call, synchronous, on the same thread. That works, of course, because whatever CDI container you're using on the server does that. It works in the client the same way, synchronous event dispatch. But the thing that we've added is that you can also observe events on the other side of the connection between the client and the server. So if you fire an event on the client when somebody clicks a button, and there's a CDI observer on the server for that event with that set of qualifiers, then Errai will serialize the event object, move it across the wire, and invoke the method on the server side with that event object. So this gives us a way of building highly decoupled distributed systems.
Yeah, so the fundamental vision here in Errai is we really want to have a uniform programming model across the client and the server. So it really shouldn't matter where your code is written for. You should be able to replace it at any time. And another feature we can use in the browser now that comes from CDI is producers. So in that example we've just seen where Jonathan injected an event of type T, and all that injection, sometimes you need more control over that. Sometimes you need to be able to manipulate that object before the container injected into your bean. And that's exactly what producers are for. So in this example here, we see that we're producing a widget, and that was qualified with supported. And the point here is that we could check at runtime whether or not like an HTML5 feature is supported, and then just return a different bean type from that method. And when you, anywhere in your app, you inject the supported base widget, it will just inject the right instance of it. So that's just CDI producers that act as a source of objects to be injected and give you more control over dependency injection. And again, that's now working in the browser.
Now, before we move on to this next feature, I'll just talk how I highlighted that we had this highly decoupled eventing mechanism that works both on the client and the server and across the wire. And I'll just share a quick story with you about an application I was working on about 5 years ago at a different company. It was a Swing application. And we just really fell in love with this event-driven programming model and all the benefits that building a decoupled system gave us. And we took it actually too far. We ended up hitting a complexity wall with our event-driven programming, where we were trying to coordinate too many things. Competing things were actually mutating state in the same object from different observers. And the whole thing just hit the wall. And we spent actually quite a long time trying to keep it event-driven and highly decoupled. But really the only way we were able to solve that problem was eventually to simply introduce a bit more coupling and couple some of what had been just listeners right into the code with direct calls, so we could control the sequence of when these different mutators were happening. So what I'm getting at is sometimes you need something that's a little more highly coupled than just a distributed event, and that's where these remote procedure calls come in. So if you've used the Google Web Toolkit before, or maybe if you've just read about it, you probably know that GWT comes with its own RPC mechanism. We've come up with one that we think is a lot simpler to use. We've reduced the boilerplate significantly. And again, like Christian said earlier, we have a really nice marshalling framework that we'll get to in a moment that removes much of the burden of getting the objects and the return values across the wire. So just quickly, how to make a remote procedure call in Errai. You just declare an interface. You put it in the shared package because the server and client code need to know about it. On the server side, you annotate an implementation of that interface with @service, which is an Errai annotation. And then you put your method bodies, whatever you want to do, return the values you want to return. And on the client side, you inject a caller of happy service. And caller is an Errai library type, but you probably see a lot of similarity with the CDI event interface. Caller works very similarly. You put your own stuff in there in the type parameters. So we're injecting a way of calling happy service. The container provides the instance for us. And then we go happyService.call, a bunch of junk, and then .isEveryOneHappy. And because .call returns the type parameter of caller, that .isEveryOneHappy is something that Eclipse is very happy to autocomplete for you. Now this junk in the middle, if you guys were at the technical keynote on Sunday, Brian Getz said something about beef to bun ratio. And we're not too happy with the beef to bun ratio in this anonymous inner class here. Unfortunately, there's nothing we can do about it in the browser because we have one thread on the client side. If we were to make a blocking call here, everything would freeze up. The whole browser UI would freeze up until the server responds. So we have no choice but to have a callback. And we hope We hope to improve the beef to bun ratio if maybe one day there's Java 8 support in the GWT compiler. But for now, when we need tighter coupling, we're stuck with this.
Okay, so how does the communication work when I do an RPC here? What happens?
Well, that's a good question. How does that work? Well, the setup in Errai is that on the server there is a bus, an Errai bus object, and it federates with each of the clients. So when you start up a GWT application by hitting the web page that's the entry point, the host page for that application, there's some startup code that goes and talks to the server, negotiates whether or not the browser and the server support HTTP long polling or maybe WebSockets, and they make that negotiation and they federate their buses with each other, figure out who's observing what and all of that kind of stuff so nothing unnecessary goes across the wire. And it also allows us now, of course, because we have a commit channel or even better, maybe a WebSocket, to push events in both directions with no delay.
I have a confession to make here.
What?
Before joining our team, I don't think I would have ever touched a message bus.
A message bus?
Yeah.
You mean over HTTP?
Yeah.
You don't like that?
No.
I think I know where you're going with this. I think you're one of those Rastafarians.
Yeah.
I think that's what's happening.
My name's Christian. I'm a Rastafarian.
Right.
I apologize.
Well, that's fair. I probably am too a little bit. So what do we do to fix this? Everything we've talked about so far, this is not terribly RESTful.
Yeah. Well, it turns out that we can use that exact same API that Jonathan just explained for RPC for REST calls. So what we see here is that add remote interface was replaced with an interface that's annotated with JavaScript annotations. And those annotations, of course, describe the HTTP traffic that takes place to invoke an endpoint. And now, the cool thing here is that we'll, again, on the client, just inject a caller for that interface and invoke a simple Java method on that interface. And that will carry out the plain HTTP REST call as intended by Rastafarians. Right.
So that's great. I mean, this bottom code block looks exactly like the bottom code block we had earlier with the Errai RPC. But now we're REST clean, and we can decide exactly what the HTTP traffic is going to look like.
Right. And that interface, you can either, using JavaScript, implement on the server, which would expose those endpoints of HTTP, or you don't have to implement it at all and just use it to contact another application or even a third-party RESTful service. And you can just use it on the client side only.
Right. So you could even use this if you've described the API, say, in some interfaces. You could use this to talk to your bug tracker or Google Maps or whatever.
Exactly. Yeah.
Right.
And the really cool thing here is we don't see any request logic or any serialization logic. And that offers the possibility to do a lot of really cool refactorings. And we'll show that in a second in a live demo. But speaking about serialization first, is that all it takes for an object to be serializable in Errai is this one annotation here that's called portable. And what we see here is a simple POJO. So that's not a surprise. Like every marshalling system can serialize that. That's not so impressive. The next thing we did is we wanted to be able to offer a lot of flexibility for marshalling. So we don't want to impose any limitations on the beans that should be marshaled over the wire. So for instance, here we could just remove the getters and setters, and it would still work.
Okay, but I've seen that trick before too. I still feel a little bit constrained because one of these other things that keeps me awake at night is when I deploy an application that's got some mutable state, especially if it's shared. But even if it's not shared, mutable state is where your bugs come from. They're the things that make you not get home for dinner. So
yeah, well, we want to get rid of immutable state because it's really just a big surface where bugs can occur. So if you advance the slide, we'll see that we're also able to support immutable entities. So all it takes is here we see it has a private constructor and a factory method. So once the bean is created, it can't be changed. And all it takes in Errai marshalling to make that work is this one extra annotation maps2 that maps the factory method parameters to the bean properties. That's all it takes. And now we have an immutable, marshalable entity.
That makes me happy. And the beef to bun problem here with maps2 may hopefully go away as well, because as far as I know, Java 8 is going to give us method and constructor parameter names in reflection finally. So the maps to is just there because we don't actually know what those parameters are called when we're building all this stuff.
So by now we've seen a lot of code snippets. I think it's about time we show that this actually works. At this point, we also wanted to sacrifice a chicken to the demo gods.
Yeah.
But we took the chicken with us to Pearl Jam last night, and it's still waiting for the bus. So
yeah, the chicken is stranded in that bus queue. So
I guess Jonathan starts with the demo.
Sure. So what I'm going to show you here, excuse me for a moment, just move this here. So what I'm going to show you here is the little demo app that we've prepared for you. So this is an Errai application, a very simple one. And what it does when the page loads is that it makes a REST request using that caller API back to the server. And it gets this list of customer objects and populates the table with them. And that's exactly what we've seen here. We can see what the data looks like by coming over here. I think we have it already.
Yeah.
There it is. So this is just a JSON payload that comes back from our customer's resource. That's a JAX-RS resource. And the JSON type here, it is an Errai format of JSON. It includes a lot of type information, as you can see. But it's actually structurally very similar to Jackson. And we actually provide a Jackson converter if you'd like to interoperate with existing Jackson-based resources. The other thing we can do, of course, is post a request back to that service. We do that, it makes a post request, and it appears in the list. So, very basic demo. Let's have a look at the code. So we see here in the structure, I'll just make this bigger so you can see it. Just like we went over earlier, we have a local package, a client local package that contains the code that's going to be compiled to JavaScript and run exclusively on the client. So this code won't make it to the WAR file as Java classes. Then we have this shared package, which is both compiled to JavaScript as well as class files and deployed to the server. And finally, we have the server package, which is not compiled to JavaScript at all. It just stays as class files and works like any other stuff you would do in a web application. So let's dive in and take a look at this app.java. So when the page loads, because this is an entry point class, Errai is going to create an instance of this class and call its post-construct method. This is another CDI feature, post-construct. So we initialize the page by adding this customer table to it. We call the populate customers table method, which is right here. And this is one of those callbacks like we saw earlier. So it's a remote callback of list of customer. We receive the response from the service just as a list of customers. We don't have to do any marshalling. It's not a string or a JSON object. It's actually a proper list of customers. And we add them to the table. And the way that we put all that together is we just go with this customer service, which was injected for us right here, caller of customer service, .call list callback .list all customers. So that's great. We'll take a quick look at the interface, the JAX-RS interface.
It's open.
Oh, thanks. It's already open. There it is. So this looks like any JAX-RS. There's no special Errai stuff in here. I'm sure everyone's seen this before. We just, for example, the list all customers method is annotated with get, so it responds to get requests. It produces an application JSON response type, and it just returns the list of customer. And Errai takes care of the marshalling when the response happens. So what have we gained from all of this? Well, one thing that's neat, if I do call hierarchy here, just hit Control-Alt-H, this is interesting. So this is a JAX-RS resource method, and we've got a caller. Who is it? Hey, it's this client-side code that we were looking at earlier. So that must mean that I can also do this. maybe I want to say list all customers, whoops, by name. Okay, so I just renamed that resource method. I happened to be in client-side code at the time, but of course I can go back here. I can also look at the implementation. This is nothing magical. We do this every day in Eclipse or whatever IDE we use. But the really neat thing is that it has updated client code and server code trivially. The other thing we can do, which is maybe a little bit more special, is that let's say we've built up a big collection of JAX-RS resources, and we haven't really agreed on the language we want to use. So let's say that we wanted to standardize on singular names in our JAX-RS paths. Instead of customers, we want customer. And if we have a method that lists a bunch of customers, we're going to give it a name of list. So we'll have /customer/list now instead of customers. Now, I've done this lots of times over the years, and what I would do now after this trivial change is I would go through all of my client code and update it all. Everywhere where I had said customers, I have to say customer. And everywhere I say customers without an ID, which was a list, I now have to go in and put list. But because our client code, our callers are generated for us, this is already done. I don't even have to touch the client code now. So if I simply restart this embedded server that's in dev mode here, restart server, there, come back to the browser. We'll explain why that happened in a minute. It's expected. And here. So this client has just booted up, made its REST request to /customers/list, and it got the data back. You can look here. That's a 404 now, as expected, because we changed the path. And of course, it is at the new location. So that's it. We've just made a potentially serious change to all of our JAX-RS paths, and we didn't touch a line of client code, and it's all still working great.
Yeah, that was really great. But what if I wanted, when you create one of those customers, what if I wanted all clients to update? Because right now you create a customer and only your view and the client will see it.
Right, that's an excellent question. And the answer might be one of those CDI events, those very unrestful push events. Might help us to update all the other clients.
Yeah. So although I like REST, sometimes push messaging is an excellent use case for a message bus. I will just quickly show what it takes in Errai to get that feature implemented. So the first thing we would need to do is we go to our server-side implementation, and we're going to inject an event of type customer and call it the new customer event. And we're also going to qualify it with new so that if we have different customer events, we can differentiate between those when we observe the events. Let me just organize the imports here. Yes. Okay, now I have an event. So when somebody creates a customer, I'm going to fire this as a business event so that other components in my app can observe it. So I'm just going to say new customer event, fire customer. So that's great and all. Now my server-side component fires an event. But now I can switch to my client-side code, app.java, and I can observe that event now. So I'm saying public void on new, let's call it customer from server. I'm saying it observes new customers. Okay, organize the imports again. And what we're going to do is we're just going to add it to the table so that we'll see it happened. So we'll call this a customer, and we add a single customer. Okay.
Okay. I think we just watched you write about 4 lines of code there.
So yeah, I have to restart the server again because I changed server-side code, but we're working on that with 0 turnaround. So we just didn't finish the JRebel plugin in time, but it will be there shortly, so you don't even have to restart the server again. But that's not the point of the demo, it's really that you can refresh the browser. But in the next couple of weeks, you'll certainly also be able to skip that restart server phase. So I think I restarted the server. Now I'm going to refresh that client again. There, I haven't broken anything, that's good. So to simulate this, we need a second client. I'm just going to open a new tab, which is a new session in Errai. It goes over. OK, so what I want to happen is if I add a customer here, it should also appear here, right? If I'm not mistaken. So I'm calling this a new customer. Add a postal code. And storing it. So it appeared here. And it also automatically appeared here. So I had to write 4 lines of code to push a message out, a change set out, a business event out to all clients that are connected at that point in time.
Yeah, that's pretty fun.
Yeah, and it's fun to do. And really what we've shown here is by working with the same language on the client and the server, we have all these amazing opportunities for refactoring across the client and server. This makes the evolution and the maintenance of the apps so much nicer and easier.
Yeah.
For large scale
and not even just for the tooling of the refactoring and the renaming, but just even knowing if I wanted to delete this attribute of customer, what's it going to affect? Well, we get an answer that even reaches out into the user interface layer, not just to our sort of API layer that the browser talks to.
OK, so let me just get back to the presentation to show some of our newest features. JPA in the browser. So we wanted that feature because basically all of our users use JPA on the server. So we want them to be able to reuse not only their entities on the client, but also their business logic. So you can now use the JPA entity manager on the client. So here we see a button click event that uses an injected entity manager and persists an entity.
Right, and this isn't storing on the server, right?
No, that's the amazing thing here. What this is going to do, it's going to persist that entity in the HTML5 local storage. So if we advance the slide, we see this is Chrome's development console. We see that album entity, it has a name query, it's like a standard JPA entity. And by using the JPA code on the client, this entity just is stored as a JSON structure in your browser's local storage. So the point of this is that you'll be able to support offline mode really easy. So you detect that the server is gone, but you could still complete the business transaction, at least partly. So when your user comes back and the server comes back online, you can just finish the transaction.
Right. So we're showing this entity class album here, complete with some JPQL named query. It's got an ID that's generated, and we can do all of this stuff through the entity manager on the client side, and it works largely the same as it would on the server side. There's a few caveats that we've documented. We're not at 100% API coverage on JPA, but it's a very useful subset. You can build stuff with it.
Yeah, it has a 5 megabyte limit, I think, local storage, but that's pretty good. Yeah.
What else? Errai UI. I just made a brief reference to this at the beginning of the talk when we were talking about UI Binder, which you're probably familiar with if you're already a GWT user. So Errai UI, what we're doing here is similar in spirit to UI Binder, but as you can see, this template here is not an XML file. This is an HTML5 document. This is a valid HTML5 document. They took away a lot of the boilerplate for us, like you don't need a head or a body tag anymore. So what we have here is what we like to refer to as a designer template, because as you can see, there's a style sheet reference in the document. So your web designers can work directly with these in whatever their favorite tools are, and anybody can preview them in a browser without actually running them through a template processor. It's just an HTML5 file. It's valid. The browser will display it, and it will look right. So let's just walk through what we've done here. You probably noticed that we have these data field annotations, like at form data field equals form, the input data field equals username, and so on. So these data fields are attributes that link up from the template back to the Java class that's the companion to the template. And we'll switch over to that now. Just remember we have a form, username, password, and a submit button. So here they are. They've come back. We have the username, the password, and the submit button. And again, we're using this CDI programming model where we're injecting the instance of text box. But we've added this data field annotation, which tells Errai that in this templated class, when you're injecting a text box for me, this is a standard GWT widget that wraps around an input type equals text. I want you to give me the element that was in the DOM that is that text box and just put it in that username field. So that's hooked up now. Same with password. We're just demonstrating here if you can't or don't want to name your field the same as your data field in the template, you can provide the name. So in this case, it was pass in the template and it's password in the Java class, no problem. And finally, there's a third scenario for getting data fields hooked up between the HTML document and the Java class, which is I don't want you to pick it out of the document and stick it into my class for me. I want to provide the instance of button to you, and you put that into the template for me where the data field existed. So that's that third scenario. In this case, it's trivial. We've just created a new button for no reason. But if you have some special needs, you need to create a special widget, you can make one, and Errai UI will stick it into the document for you rather than pulling it out. So that's all there is to hooking up the structure between a template and a class. Now what about behavior? Well, here's how we have managed to get rid of one of these anonymous inner classes that nobody likes to write or look at. You simply say @EventHandler, you give it the name of a data field, and you can call the method whatever you like and tell it what type of event you want to receive from that element. So in this case, anytime there is a click event originating on or bubbling through the submit data field, this method will get called with that event object. And we've got just a little comment here. It's a bit insidious. It says send login request. So how would we do that? I think you can imagine how we would do that. There's probably a class called user somewhere in this application. So we'd probably say user equals new user. Sound good so far? Then we'd say user.setUsername, username.getText. Still sounds good. User.setPassword, password.getText. Okay, I'm getting bored. How can we fix this? This sounds like boilerplate to me.
Exactly.
These are lines with 2 or 3 of the same word on them.
Yeah, so the good thing is you don't have to write that code. So we have a new module that's called Errai Data Binding. And while you can use it as a standalone component, it has a Fluent API, it's also integrated with Errai UI. So it just takes these 2 annotations here, auto bound and bound, to bind an instance of a model, the user object, to the UI, to the data fields. So what happens here is that the user is bound to the mapping fields, username and password, and it's automatically kept in sync. So anytime you change, you call username user.setName, the username will change, and anytime you change the UI, the model will update automatically. So you don't have to write any of the boilerplate event handling code to update the UI in response to model changes or to update the model in response to UI changes. The framework generates code for that and it will take care of it.
But do we lose all of this nice security and type safety that we had when we wrote everything out longhand?
No, that's the cool thing here, because we have to process that annotations and generate code. When we find mapping problems, we can just fail at compile time. So let's say our user object here doesn't have a username property, Java Bean property, which just tell you we can't bind to the username text box because there is no username property in user, and then you would have to specify which property as an attribute of bound you want to bind to.
So when we redeploy our new app on Friday evening and then go out for drinks, we're not going to get a surprise call because we forgot to line up the naming fields or anything like that?
Well, let's put it this way. You're less likely to get a surprise call.
Okay, that's fair. So that sums up the breadth of the high-level features we want to talk about. There are some lower-level APIs inside of Errai that we're not going to get into today, but we'd like to take our last few minutes that we have to talk a little bit about how all of this goes together. Like, how do we implement these traditionally server-side APIs to run in a significantly different execution environment, like a web browser?
Yeah, so many of you probably have written framework code or frameworks already. Java Web Framework has been around for a while. And they all have one thing in common, massive use of Java reflections. That's really what they do. Unfortunately, in Git or in the Google Web Toolkit, there is no such thing.
Ow. Well,
Yes, ouch.
how do we do this? We don't know what everybody's code says. How do we get along without reflection?
Well, there's this feature in Git. We can't really do justice in the few seconds or minutes we have remaining, but it's called Deferred Binding. It has two main use cases. The first use case is to replace a type. So when a compiler finds a type, it can replace it with another type. That's used by Git internally to generate all the different permutations for the different browsers. So Git doesn't just compile one version of the JavaScript, it compiles many versions for each browser separately. And it uses that first feature of deferred binding where the compiler sees, oh, there's a pop-up implementation used, and if I compile for a Mozilla browser, just replace it with one that works there.
Right, and a big reason, the motivator that lies behind this from Google is that because there are significantly more quirks for some browsers, you could probably fill in what those might be in your mind, we don't want to punish everybody by having them download all of the compatibility code for that browser if they happen to be using another browser that's much closer to spec.
Yeah, exactly. So you only download the JavaScript in that browser you're working with. It's all the JavaScript it needs. It doesn't need all that other JavaScript to check for other browsers. So the second feature, and that's the one we use heavily, is code generation. So when the compiler encounters a type, it can generate an implementation of it or another type that's used for it. So that's used for RPC, for instance, for the Caller API, where we just refer to an interface and we invoke the method. What happens there is that the implementation of that interface on the client, a proxy, is generated, and we invoke a method on that proxy that does all that communication with the server. So code generation is really our replacement for Java lang reflect.
Right, and I'll just point out that this looks like not only XML configuration, but maybe a little bit of boilerplate. You don't need to do this in your own applications. Your Git module will inherit our Git modules, and you don't need to write any of this deferred binding configuration.
Yeah.
It's just there for you. Your Git module descriptor will be very simple. It just inherits the parts of Errai that you'd like to use. So what does this generated code look like? It sounds kind of scary. Is it ridiculous?
That depends, I'd say.
Well, here's one. This is an example of the type of code that would be generated for one of those JPQL queries that we saw earlier. So in this case, this was a query we saw earlier in the presentation. Select A from album A, where A.name equals a parameter called name. So it's not that much code, really. It's as much code as you would write by hand to do something like that. But if you could write that one top line by hand, just the part in green, rather than this page full of code that does the same thing in Java, wouldn't you prefer to write the top one? I think it's more fun to maintain and even easier to understand at a glance.
Yeah. Okay, so we hope we've shown you how to get from this twisty maze of little callbacks to this.
That's some tame spaghetti. So now you know everything there is to know about Errai, and thank you for coming out to our talk and giving us your time and attention.
Thank you. Yeah, we're still here for questions, of course. Also, don't hesitate to get in touch with us, of course. Everything we do is open source. You find us on GitHub. You can join our IRC channel or ping us on Twitter or wherever. We're really interested for feedback and questions.
And as you can see from the background picture, the whole Errai team happens to be based in Toronto. So if you're in Toronto, come out to the local user group and chat with us there.
Yeah.
Questions?
Please.
That's a really good talk. Thank you. That looks really, really good.
Thank you.
I have a bunch of questions. I don't have one plus one before though, so I think maybe two I'd like to ask most. Is there any consideration to using this on mobile, to support mobile? I know that GW's here probably had a mobile component, but I think it might die. And the second one is, what about security and serialization and considerations around serialization, like serialized objects online if you're pushing out events?
Right. Okay, two great questions. The first one is about, does this work with mobile? Are there any special considerations we need with mobile? And of course, there are many Git frameworks already that work with mobile, and can you use them together with Errai? That was the first question. And the answer is yes, it works great with mobile. We actually have a demo that we've done. It's a very lightweight, low-level demo. We didn't bring in any new mobile frameworks, but we're just showing how you can get the HTML5 orientation events from the device and use them. We actually bridge them over to CDI events and stream them up to the server. So we could show you that after. We'd be happy to. And the second question was about security and a little bit about the overhead of all this serialization that's going on. Do you want to take that one, Christian?
Yeah. That is hard to answer. So one thing you do is, the main reason for the portable annotation when it was designed was for security. So we only expose the types you want to be exposed. So when something is not portable, the client will not see it. So that's really the most coarse-grained security mechanism we have is this annotation. That's the only reason it's there for, to mark something explicitly as portable to be visible to the client. So in that sense, it's in your control what's visible and what not.
Thanks. In terms of serialization and throughput, does serialization, I mean, I'd rather use browsers because it's just plain text.
Right. Actually,
Yeah.
Oh, do you want to?
You mean that the JSON format would be too heavy? Or?
Java serialization objects.
Yeah.
Yeah. It's actually very fast. We've done some benchmarking on it, and we're very pleased with the results. Inside of the browser, we're using, whenever available, we're using the json.parse method, and it's shockingly fast. I had a huge payload, far bigger than you would want to design for, like many megabytes. And json.parse came back in no perceivable time. It had parsed it already. It might be a little bit lazy, but it doesn't matter. It's so fast you can't see it going. And on the server side, we have actually written our own JSON parser with the primary goal being performance, and it's extremely fast. We can chew through megabytes of JSON in no time at all.
Another reason it's so fast is because we use statically generated marshallers. So we don't have one marshalling framework that just happens to work with all those annotated classes. The moment you annotate a bean with portable, we generate a specific marshaller instance for that particular type. So we can really optimize on a field level for your particular bean how we marshal it. There was another question?
I use GWT with Request Factory. So when I'm sending objects back and forth between the client and the server, it sends only the stuff where it's changed. How would that compare with the performance of Errai's RPC?
Well, in RPC, you would always send the whole object. That's correct. So you'd always send the full object. But if you could implement lower level events, then use a CDI event for just a change set and push that to the server. But yeah, that's correct. If you do an RPC, you get the full object, not only the change set right now.
Well, I have one more question. We said at the top of this talk that server-side rendering is dead, but is that really true?
Well, no. We might actually be introducing a feature where you could render parts of the UI on the server.
Right. This is a trick we've read about that Google Plus uses heavily. Although it supports incremental updates for everything it does, it also pre-renders the page and pushes down a bunch of HTML to you when you first hit the site, and that's what makes it look like it has loaded so fast. And according to this article that they wrote, if you try to click those buttons, as soon as you see them, they don't actually do anything yet because it's still downloading JavaScript in the background. It takes a second or two before there's behavior on the page, but you can't tell because you're still just trying to figure out what you're looking at. So server-side rendering isn't really dead. What's dead is exclusively server-side rendering. And so we're really keen in the next version of Errai to see how we can use these Errai UI templates, render them on the server, render them on the client, get exactly the same results in each side. So when there's the initial page load, you see a fully formed UI that's correct, and then a few seconds later the JavaScript catches up and it does something. So we're interested in implementing that in the future.
Yeah, and another future thing we were going to work on, which I forgot to mention, is that when we persisted the JPE entity in the browser, one obvious question would be, which I forgot to ask you, how do I keep those entities in sync? When the server comes back online, somebody else might have changed that entity and I have it in the browser.
Yeah.
What's going to happen there?
Right. So that's what I'm looking forward to getting into as soon as we get back to Toronto. The idea we've got is if you take a JPQL named query, complete with parameters, and a where clause, of course, you can specify this little slice of your overall database. It's more than likely going to be data that's of interest to only one user, like the person who's logged in, say. And it will probably even be a subset of that, like maybe the stuff that's on their initial home screen, so that you can keep it in the client. So you get this little JPQL query that extracts the information that just that person is interested in, and then you give it to this Errai method. You say, take this query and give me an object that has all of the results of this query in it and keeps them in sync so that the result set of the query remains the same on the server and the client, and whenever something new enters the entity manager that matches that query, it will get added to that set, and it will be present on the client and the server as instantly as possible, assuming that they have a connection and you're not in offline mode. Similarly, if the entity manager notices an entity being removed and it matches the query, that state can be synchronized as well. So we think this is going to be great. We just need to get to work on it and see if it's as awesome as we hope. Anything else? All right. Oh, yes.
In terms of context, work well with arrays and leaf DTO. So you don't require to say, lists.
Right. That's an excellent question. It's about complex objects, and do you need to build DTOs to sort of constrain the set of things that's going to get matched? So we're hoping we can use the fetch clause in the JPQL query to prune the set of things that are going to be fetched. So even though the semantics of the query say, well, those will still be lazily retrieved if you cross those boundaries, we'll use that as more of a hard limit, where anything you didn't fetch eagerly is simply not considered to be part of this syncable data set.
That also gets rid of that proxy problem, right? Of serialization.
Yes, we like to try as much as possible, both in our CDI implementation and our JPA implementation, to not require proxies around things. So as much as possible, you're working with just raw objects, which gives us maximum speed and minimum size. Yes?
Yeah, on your data binding slide, you show that you can inject an auto bound. Yeah. So why can't you just inject the user in the constructor? What does the data binder brings besides the get model?
That's an excellent question, actually. We're even working on a way to just inject an add model with a user annotated with model, so we bind it together. The reason we injected data binders, and we had a lot of discussions in the team about that, is that you often want that bindings to be mutable. So what happens here is the data binder. I agree.
I fought against.
That was the discussion exactly. So what happens here is that data binder, the framework is calling the bind method on it for all of those fields. But having the data binder, you can continue adding more bindings or removing bindings. Plus the data binder has a lot of nice utility methods to get access to changes and to figure out if something changed, or to register property change handlers. So the data binder has just a lot of utilities you can use. And in every demo we built so far, we always needed to invoke one of these methods. So this is the reason why right now we're using the data binder, but as soon as in the next release, we'll have a model annotation so you can inject the model directly. Yes, it's a good question.
Great, thanks. We just have 2 minutes left, so we can take one more question if anybody's...
We'll be staying around here, though. So if
Great, yeah, well, I hope we have a chance to chat with you later. Thanks again, everyone.
Thanks for coming.